Okay, so we spent the last couple of days solving equations and got a little comfortable with that. Now we're going to talk about where we can see different equations in math. So it's going to look like different kinds of questions, not just here's the problem and solve, which most of the time it is. But they're going to be different types ranging from pictorial, which is like a model here, word problems, which we'll talk about in a couple of days. But let's talk about pictorials, what we call models in algebra or in math. So imagine that you have an equation on a balanced beam. The idea is we want to keep each side balanced, and in order to do that, or while we're trying to keep it balanced, again, just like we've been doing, we're trying to isolate the variable. Now, for the purpose of today, this is just honestly the same thing we've been doing. So when I look at a pictorial, I need to be able to make my own equation from this picture, this model. And most of the time, they do give you a key on what each image represents. For instance, this long white rectangle represents x. The little white squares represent constants, which is your number itself, so the squares them. If it was shaded at all, those normally represent negatives. And of course, with negative rectangles, if there were any, then those would imply negative. Now, let's talk about number one. So how many white rectangles are there? There's one. So that would be 1x. How many individual squares are there here on the left? There are 6. And since we assume that y is positive, it would be plus 6. And on the right side, if I count the squares, it would be 3, 6, 9, 10, 11, positive 11 on the right. And then if you look at my equation, it's literally what we've been doing for the last couple of days. So we draw our line down the equal sign, look at the side where the variable is. I see multiplication and I see addition. Or remember, just like the last couple of days, we're going to take care of addition first, which means I'm going to subtract 6 because the 6's 0 out. I'm going to bring down the 1x because I haven't touched it. Right here, they are different. One's positive, one's negative, so I do subtract. 11 minus 6 is 5. And since 11 is bigger, it's positive 5. Now, because technically this is multiplication by 1, the opposite of multiplying is dividing by 1. And a positive divided by positive is a positive. 5 divided by 1 is 5. So x equals 5. So let's do that again. Pictures can vary, so sometimes they use different things to represent different values of the equation. Now, if I look at number 2, it's a little hard to see, I apologize. If you look at the squares, they have x's within them, and the circles have digits within them. So that's their way of giving me a key without the key. So if I look at number 2, there are 3 x's, so 3x. There are 3 circles with 1s inside, so we're going to assume they're positives, so it'd be plus 3. Equals, which we assume the left and the right is the equal sign. And then 2, 3, 4, 5, 6, 7, 8, 9 circles on the right, and those are positive, so I'm going to keep them positive. And then we solve. We're going to draw our line down the equal sign. I see multiplication, I see addition. The opposite of addition is to subtract, so I'm going to do minus 3. The 3x we haven't touched, so I'm going to bring down. The 3's 0 out. 9 and 3, so one's positive, one's negative, which means we actually do subtract because they're different. So that 9 minus 3 is 6. Since 9 is larger, 6 is positive. Then the opposite of multiplication is division. So remember, I make it look like a fraction symbol because a fraction is just division. And positive divided by positive is a positive. 6 divided by 3 is 2. So the math is no different than what we've seen the last couple of days, just with the picture. So let's keep going. This one has 1, 2, 3, 4, 5, 6 rectangles, which we assume represent x, so 6x. Then there's one white square, which is positive 1, so plus 1. And on the right side, we're going to assume that these are negative squares, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. But since it's shaded in, we're going to assume that's negative 11. So unless we're told otherwise. Then we draw our line down the equal sign. I see multiplication, I see addition. We take care of the addition first. The opposite of adding 1 is to subtract 1. 6x we bring down, and the 1's 0 out. Since these are both negative, this is what's killing us these days. Since these are both negative, that means they're the same, which means I actually add them together, which means 11 plus 1 is 12, and we keep it the same sign. Then see multiplication, which means we're going to divide by 6. Negative divided by positive is a negative, and 12 divided by 6 is 2. So it would be negative 2. And then it gets pretty repetitive. Number 4, I have 4 white rectangles, which we're going to represent as 4x. I have 3 solid shaded squares, so that's -3, which we're just going to put -3. And then 2, 4, 6, 7 negative squares, so -7. So then we draw our line down the equal sign. I have multiplication, I have subtraction. Subtraction goes first, and the opposite of subtracting 3 is to add 3. What I do to one side, I do to the other. Since I haven't touched 4x, I'm going to bring it down. Now, one's negative, one's positive, which means I don't actually add, I subtract. So 7 minus 3 is 4. And since 7 is larger, it's -4. And then the opposite of multiplying is to divide. So the 4's cancel out. Negative divided by positive is a negative, and 4 divided by 4 is 1. So -1 is my answer. On this side, triangles, again, you notice that they have symbols within them. The x's are in the triangles. I have -1s in these circles and +1s in these circles. So I have 2x. Since these are negatives, it would be -4 or -4 if you want to imply like that. And then 2, 4, 6, 8, 10, 12 positive circles on the right side. And then we solve. If I look at the left, multiplication, subtraction. Subtraction goes first. Opposite of subtracting is to add. So +4. I'm going to bring down the 2x because the 4's 0 out. 12 and 4 are both positive, so we do actually add. 12 plus 4 is 16 and keeps it +16. I'm going to divide by 2, and positive divided by positive is a positive. 16 divided by 2 is 8, so x equals 8. All right, again, if you look closely at number 6, there's a -x inside the squares. So, and then the positive in this circle, negatives in these circles. So we know that there's -1x. And then since it's only one positive, it's going to be +1 equals 1, 2, 4, 6, 8 negatives. So -8, and then we solve. I see addition, so we're going to subtract 1. I'm going to bring down that -1x. Since these are the same, we're actually going to add them together. So 8 plus 1 is 9, and they're both negative, so my answer is negative. And my last step is to divide. And so the -1's cancel. Negative divided by negative is a positive. 9 divided by 1 is 9. And then we just continue. Over here, if you notice, inside the squares, there are negative x's, and then a negative in the circle, positives in these circles. So I have -2x -1 because of -1. And on the right side, we have 4, 5, 6, 7, 8, 9 positive circles. And the reason why I don't have to put +9 is because it's all by itself. So you don't have to put the +9. Now, opposite of subtracting is to add 1. Bring down the -2x. 9 plus 1 is 10. Divide by -2. And a positive divided by negative is a negative. 10 divided by 2 is 5. So x equals -5. Now, I want to show you this one because we're of course, it makes it look different because the x's are on this side. But watch your digits here. Same premise. I have 3, 4, 5, 6, 7, 8 positive circles on that side. I always do my x's first when I'm doing the model. So I have 4 negative x's, so that's -4x. I have 4 negative circles, so -4. And then, just like we've done the last couple of days, this time my variable's on the right side. The opposite of subtracting 4 is to add 4. Since they're both positive, I am actually going to add. So 8 plus 4 is 12. Bring down the -4x, and the 4 is 0 out. Now, the opposite of multiplying is to divide. So I'm going to divide by -4. Positive divided by negative is a negative, and 12 divided by 4 is 3. So x equals -3.